In this small video, I want to go over the example which I noticed make many students confused. This example has two parts. We give you three integrals. Integral from 0 to 6 of the function f of x is 6. From 0 to 2, the same function gives you 5. From 4 to 6, the same function gives you 4. That basically means that this function that represents the height is the same, but on a different intervals, it gives you different answers. That's the idea. Knowing these facts, we ask you to find two things. A, find the integral from 2 to 4 of that function f of x dx. And B, find the integral from 4 to 2, which is immediately suspicious. Why would we go from 4 to 2 if 4 is greater than 2? That gives you a hint that probably we will switch the limits of integrations using properties of integrals. Of 6 of that function minus 5. A. For the A, I always see it this way. So when you stack, try to find, the biggest interval you have, and then create small intervals from that interval. The biggest interval we have is from 0 to 6. Again, the idea is that we're working on the biggest interval from 0 to 6. Then we have smaller intervals. I will put them in green. The smaller ones are from 0 to 2. Okay, so it's over here from 0 to 2. Then we have in blue from 4 to 6. Okay, that's over here from 4 to 6. And these are given. And we also have interval in yellow. That's the total thing from 0 to 6. Knowing the total and the edges, you should be able to find the middle one. And that's exactly the one we're asking you to, from 2 to 4. So for A, I will write down that the total integral from 0 to 6 f of x dx equals, using properties of integration, we can break the whole interval into small intervals. From 0 to 2, f of x dx plus from 2 to 4, the missing part, f of x dx plus from 4 to 6, the blue part, f of x dx. Check that I did not miss anything. From 0 to 6, connecting points are 2 and 2, 4 and 4. That's how you connect diagonally, basically. Now plug everything which is given and hope that it's enough to answer the question. So integral from 0 to 6 is given over here. That's 6. So I have 6 equals. Integral from 0 to 2, that's the second one, that's 5. Equals to 5 plus integral from 2 to 4, that's the one we don't know. So I'll write it down. From 2 to 4, f of x dx plus. And finally from 4 to 6, in purple over here, that's 4. Now just solve for the missing part. Then missing part is integral from 2 to 4, that's the one we ask you to find, f of x dx equals 6 minus 5 minus 4. That gives you 1 minus 4, which is 3. 1 minus 4 is negative 3. Yes. The answer is negative 3. Since the answer is negative, that gives me a hint that the area probably is below x-axis, like that. Okay. That's A. Most of the people are stuck with B. And I know why you guys stuck with B. Because of the last step over there, which is a little bit confusing. In B, we are asked to work with the integral from 4 to 2, 6 f of x minus 5 dx. Zoom in and start working with this beast. Okay, what do I know? I know how to break integrals in pieces, and that's what I'm going to do right away. I will create two integrals from this one integral. And also, I first gonna break and then I'll do step by step to make sure you avoid mistakes. The first integral will be from 4 to 2, 6 f of x dx minus integral from 4 to 2, 5 dx. No x there, right? Just 5 dx equals. Now, You see the 6? Let's kick it out. Then I will have 6 integral from 4 to 2 f of x dx minus, and then I will have integral from, now here I can do this way. There are several ways to see the second piece. I don't like that it is from 4 to 2, so instead I will change the sign to plus, and I will do from 2 to 4. I'm using here the property that integral from a to b is minus integral from b to a. Make sense? That's the property we had. Check it if you don't remember. 5 dx. The first piece is almost ready. We are given here integral from 4 to 2 f of x dx. But we found integral from 2 to 4 f of x dx, and that integral is -3. So I will switch the sign for the first integral as well. I will put in the red color the negative sign. Here it is. Then I will have integral from 2 to 4 f of x dx plus integral from 2 to 4 5 dx. This guy was found in A, and it is -3. -3. So it's -6 times -3, which is 18. For the second guy, 2 ways to see the situation. If you already know how to calculate definite integrals from the next chapter, then you know how to solve this integral. But then you can say, hey, this is next chapter. How do I know how to find this integral without knowing fundamental theorem of calculus part 2? This is how we try to explain it. Integral from 2 to 4 of the function f equals 5, well, let's call it differently. It's some kind of y equals 5, a different function. It's a constant function. This situation looks like this. There's a constant function y equals to 5. And then we're integrating or finding the area below y equals 5 from 2 to 4. That's the exact rectangle. The area for this exact rectangle A area is going to be height. Height is 5. So 5, that's height, times the base. And the base is, who said 2? But how do you know it's 2? It is indeed 2 because it's 4 minus 2, right? You take the biggest number, subtract the smallest number. So if you think about the second integral just as an area, then the answer will be, and I'll write down, the first integral gives me -6 times -3, and the second integral gives me height 5 times base 4 minus 2. Basically from geometry, if you think about it. Height and base. And from remembering that area is one of the applications of definite integrals. In the future chapters, you will learn that actually integral of 5 dx is just 5x bar 2 to 4. And it's the same thing as 5 times 4 minus 2. That's from the next topics you will see, how to calculate definite integrals using the main theorem of calculus. Fundamental theorem of calculus. Fundamental theorem of calculus. So don't be afraid, but literally you will learn this in a couple of days. For now, actually, we just thought you will remember how to use areas to calculate the second part. I'm not done. I just need to find the final answer. And the final answer will be, so it's going to be 18 plus 5 times 2, right? 5 times 2, that's 28. The final answer is 28. Make a point here that we used the result from A to find the result in B for the first integral in blue. And for the second integral in green, we used basically geometry and understanding that integrating from 2 to 4, a constant function 5, also means to find the area below line y equals 5. From 2 to 4, that area corresponds to the exact rectangle with the height 5 and the base 2. based on geometric formulas. That gives me the area 5 times 2. Good job! See you next time!